Hello, this is Joe Sitter with Imaging Science and Technology, demonstrating a test of an XRG-160/160 high voltage power supply assembly that's used in an Exelon Cougar X-ray system. Of course, I don't have an X-ray tube on this system, so instead what I have is a high voltage divider with this resistor going to this meter to read the grid voltage, and that meter is floating on top of a high voltage terminal of this high voltage divider that can measure up to 160 kilovolts, but obviously with this arrangement I cannot operate at that high voltage. Over here I have a small automotive light bulb to simulate the filament in the X-ray tube. And you can see this is the high voltage cone that would normally go into the X-ray tube, and the high voltage cable that's attached to the XRG-160. Also, this meter right here is reading the divided 1000 to 1 divided voltage from that large divider over there made by Glassman. These 3 meters would be analog inputs to the computer system on the X-ray machine. Here would be the filament current, the tube current, and over here the kilovoltage readback that would go also to the front panel. And of course it's going to be scaled. I believe it will be 0 to 10 volts, or it may be 0 to 12 volts. And because that's what I'm giving it, the XRG-160 provides a reference voltage of 12 volts, and I applied that to these potentiometers that behave like analog outputs from the computer, and these are reading various digital conditions, inhibits and interlocks, and over here are controls, digital inputs and digital outputs that would normally go to the computer of the X-ray machine. Here I can read the AC voltage going in. The XRG-160 is capable of being powered from 90 volts AC up to 240 volts AC. I've got a variac transformer here, and I'm going to turn it up to approximately 100 volts, as if you were operating it in Japan, perhaps, with the AC power they have there. So there I am at 100 volts AC going in, and you can see I've already got the main power switch turned on, so you could hear the cooling fan that's over here blowing air out. And now I will enable the grid voltage by flipping this toggle switch right here, and you can read it on that meter. I'm not going to get very close to the thing right now. And there I have minus 614 volts DC, and I can turn that off and on. I won't be able to adjust it right now because there is no X-ray tube to enable the normal servo loop function. And here I'll be able to read the high voltage from the Glassman voltage divider that I've added. As it's also a dummy load resistor for the thing to simulate tube current through the X-ray tube. And then over here, this is reading millivolts right now because it's just not all the way down to 0, and that's voltage coming out from the XRG-160 that normally would be reading kilovolts, and it's not going to be scaled to anything normal. I believe 1 volt on that is going to be 16 kilovolts. Okay, so I've enabled, I've closed the door on the X-ray machine by flipping this interlock switch, and then I make sure that all these potentiometers are turned to minimum, and I'll enable the high voltage, and then slowly increase the high voltage knob, and there I've got 11 kilovolts, and climbing. And here, when I get to 1 volt, that's 1 volt approximately on this meter, that should be about 16 kilovolts approximately. It could be something more like slightly different scaling, but of course the computer software can make adjustments. Here I'm reading an output of 18 kilovolts. So over there on that terminal there is, well, now it's 20 kilovolts, 20.6 kilovolts, and the readback that requires scaling with the computer says 1.4 volts. And there you see the grid voltage has changed slightly, 610 volts. And what I can do now is increase the filament current. And pretty soon you should see the filament start to light up inside the little test lamp. Okay, and it's not going to have proper servo control, I'll say again, because there is not a true X-ray tube with, you know, that's going to change the tube current. And if I enable the tube current, it says that I have 258 microamps through the X-ray tube, and that's basically current flowing through that resistor, through the metering resistor that's being read here at 20.6 kilovolts. And then if I adjust the tube current, the circuitry in the XRG-160 is going to try to servo the tube current by adjusting the grid voltage, but it won't be able to do it properly. All I can demonstrate to you here is that the XRG-160 is trying to servo. So it's hunting, trying to make the X-ray tube behave properly. And you'll be reminded that the tube current in this type of X-ray tube, the fine focus X-ray tube, is not determined by the filament current, it's determined by the grid voltage. So this is the control where you can, where the X-ray tube current is being controlled. So basically I'm proving that all of these circuits are functional, but unfortunately, because of this installation and the fact that I'm not using an X-ray tube, I cannot run the high voltage all the way to 160 kilovolts. I'm afraid it'll arc over, and it's possible that one arc could damage the high voltage power supply. There I'm at 22 kilovolts. And turn it up a little bit more, and you can see over here, this is the reading that needs to be scaled by the software, and that would be the high voltage output. There's the tube voltage. There's approximately 1.5 amperes flowing through the filament of that light bulb, and you can see the grid voltage is still there, the light bulb is still lit up. This power supply appears to be fully functional, and like I said, I do not want to crank up the high voltage more because I don't have an arrangement here that would be able to hold off even 50,000 volts. I think that it would probably arc over around 35. So I'm afraid to go much higher, because it would only take one big arc to damage the power supply, and I don't want to do that. So now I turn the filament off, and I can turn the high voltage down, with this knob right here. Disable the kilovoltage, the high voltage. Disable the milliamps. And inhibit the grid voltage. Open the interlock, which would be like opening the door to the X-ray machine. And turn off the power to the system, the mains switch. Turn down the mains voltage. And that's it. That's the full demonstration of the testing of the XRG-160. And this is the unit right here. Sorry about the focus. Thank you very much. Bye.